So what we learned in the last lesson is that we are in this big shortage of fresh water and we are quickly running out because our use of it isn't sustainable. So we have two options. We can either make more fresh water or use less fresh water. Because population growth, we know how much the population is growing, expansion of irrigation, we've seen how much agriculture is growing, and industrial development have doubled our use of fresh water over the past 50 years. So that's a lot. So we're, like I said, we can either increase supply or reduce demand. So we can increase supply temporarily through more intensive extraction, but that's not sustainable because if we take more out of what's already there, it's not coming back faster, right? That doesn't fix our problem. We can just have more right now, but definitely doesn't fix our overall problem. We can divert water from one area to another, but that solves problems in one area while just creating them in another, which is actually how California gets its water. We solve our problem here while taking all the water from Owens Valley. Reducing demand means conservation and more efficiency measures, so we could think about that. But in lowering demand is a possibility, but that is hard to do in the long term. So one way that we can make more fresh water is through a process called desalination. Desalination, and it's taking seawater or other salt water and removing the salt from it so we can make fresh water. The salt can be removed by heating and evaporating. So basically, if we heat up the salt water and we let it cool elsewhere, it leaves the salt behind. That's called distillation. Or we can basically filter it out through membranes with teeny tiny pores that keep the salt behind. An example of that is reverse osmosis. And desalination is super expensive, uses a lot of energy, and generates concentrated salty waste. So all of the leftover salt is waste and it's super concentrated. And it also kills aquatic life at the intake. So for sucking in salt water, all the life around there would die, and so that has ecological effects as well. Currently, there's more than 20,000 desalination facilities that exist worldwide, but they're more popular where fresh water is super scarce, such as in Saudi Arabia. So Saudi Arabia is in the desert, gets most of its drinking water from desalination. There is a desalination plant in San Diego as of 2015. It cost $1 billion to make, and it's the biggest in the US, but it costs $110 million a year to run. So it's pretty expensive. A second way that we could, so instead of making more fresh water, now we're going to talk about reducing demand. So agriculture is where most of our fresh water goes. So if we find ways to make that more sustainable, then that'll help our water usage overall. So we could line irrigation canals to prevent leaks. So if we are preventing the excess water from leaving, we can use it. Leveling fields to minimize runoff. That way the water gets absorbed instead of us losing it. We can move from inefficient irrigation methods like flood and furrow, where they just flood the land. There's more than that, but part of it is flooding the land, where you lose most of the water, to more efficient ones like drip irrigation. And drip irrigation is much, much more efficient. I think you only lose 10% of water is wasted. So 90% effective is pretty good. So we could switch to that. Experts estimate that drip irrigation could reduce water withdrawals while raising yields. That would produce $3 billion extra annual income for farmers of the developing world. So drip irrigation is looking like a pretty good way to go. Another thing that we could do would be eliminate water-intensive crops from arid regions, arid meaning dry climates without a lot of rain. So if we match the plants to their climate, then we won't have to waste as much water. For example, if we grow almond trees in California, in the Central Valley, where there's not a lot of rain, it says that the almond trees that are grown there take up 10% of all the water used by the states on just one crop in one part of the state, because they need a lot of water and there isn't a lot of water there. So if we farmed those in a different part of the state, or maybe a different state where water was more plentiful, wouldn't have to waste money on it. Other crops that don't grow well in arid regions are cotton, rice, and alfalfa, but sometimes they're subsidized to be grown in these regions, meaning that the government pays for them to be grown there to provide industry to its people. but that's not very good because then the government is inducing water waste. So another way we could lower our usage is by lowering residential and industrial water waste. So water waste can be reduced in households by installing low flow faucets, shower heads, washing machines, and toilets. A lot of your homes probably have these. They're pretty common these days. We could also use alternative sources of water for gardening and lawn care to help reduce a home's footprint. So for example, we could do rainfall harvesting, which is the process of collecting rainwater with a rain barrel. So a lot of times the water companies will just give these out. It's literally just a barrel. And if you are in a region where it rains a lot, or not even, I know that they're common around here and we don't get that much rain overall, but in the winter we get a decent amount of rain, then you can use it to water your lawn later. Or we can do something called using gray water, where gray water is the used water from showers and sinks, which is funny that it's called gray water. I think that's kind of gross, but kind of funny, and can be used in some places for watering. So it is wastewater, but it's not sewage. It's just water that has cleaned our bodies or our dishes, and then we can use it in some places for watering. Another way is called xeriscaping. And that means landscaping using plants adapted to arid conditions. So in reality, the part of the world that we live in the southwestern United States, is a desert. And we plant these beautiful green lawns and beautiful trees and flowers that take up a lot more water than would naturally get from living here. So a lot of Southern California residents have changed their green landscaping to being more of this drought tolerant landscaping where they don't have grass and they have more succulents. That way they don't have to water them. And a lot of water companies have provided rebates for that. So you actually get a refund or a discount if you plant these plants, and then you don't spend as much money watering them. So I know in my parents' neighborhood, a lot of homes a few summers ago when the drought was really bad, they all switched their lawns to being drought tolerant. Here's the econ side of it. So market-based approaches to water conservation are being debated. So basically water is not treated like most other commodities, meaning that the price of it changes based on the demand, which is the supply-demand model of economics. So economics have suggested that ending government subsidies and making water a commodity with its extraction cost reflected in its price. But the problem is that this could unfairly benefit industry at the expense of agriculture. And some water systems were privatized in the 1990s, meaning that the government wasn't in charge of providing water anymore, but now private businesses were. But these private businesses don't have the best interest of the people they're providing for at heart. They're income-based organization rather than the government, which is designed to help its constituents. So that could lead to unequal access of water in some areas, and that's not what we want. We want better access to water. But what has helped is decentralizing water control, meaning that the national or larger scale governments used to be in charge of water, and they found that by switching it to the local level, there's positive impacts on water conservation, which kind of makes sense, right? Like the people who are closer to the problem would have a better insight on how to fix it. So nations often cooperate to solve water disputes. So water is a very, very important commodity, and some people have more of it than others. And there are fears that the unequal access to fresh water worldwide could lead to conflict between countries. So what this map is showing is the bodies of water that are under, like the water basins, so the watersheds that have potential for dispute because they are cross borders. So you can see the red ones are potential for conflicting interest, especially a lot in Africa and sub-Saharan Africa, or all of Africa. There's a lot of desert there. Same thing with Southern Asia. The orange is that there has been a recent dispute there, and the yellow is that there's other international basins. So we're not fighting with Canada over our water, but we share watersheds with them. Most of northern South America shares a watershed also. So a total of 261 major rivers cross national boundaries, making disagreements common, because if one country feels as if another is taking more water than it's shared, water isn't something that we can get by without. right? Like people need water to survive. So something that definitely can lead to disagreements. And so far, many of the nations have cooperated to resolve these boundaries. So, for example, India has struck agreements with Pakistan, Bangladesh, Bhutan, and Nepal to co-manage transboundary rivers.